Hey guys, coming at you again to talk a little bit about determining the size of an earthquake. And so, oftentimes in the news, you hear earthquakes reported in terms of their magnitude. And so, magnitude is a measure of ground motion, and we can actually determine the amount of energy released during an earthquake by understanding its magnitude. Intensity is referred to really more as a physical property and can be determined based on the amount of damage that's done during an earthquake. So there are two different scales that we use to fundamentally measure earthquakes. And so the first scale is called the Modified Mercalli Intensity Scale, and this was developed by an Italian, Giuseppe Mercalli. And this is a measure of the amount of damage through physical observation. And depending on how far you are from the earthquake epicenter, the scale varies a little bit. So here's just an example of the modified Mercalli intensity scale. Now, obviously, if you're closer to an earthquake epicenter, you're going to feel more of these physical manifestations than if you're further away. So, on a scale of 1 to 12, Roman numerals, a measure of 1 would be not felt at all. A measure of 5 would be felt by nearly everyone. Many awakened. If it happens during the night, it can cause disturbances in the form of objects falling off shelves or trees swaying or buildings swaying, etc. If you move up the scale, say Mercalli index of 10, you might see structural damage. So there might be buildings that come down, including wooden structures that have a little less integrity. You might see some breaking of brick and masonry and frames destroyed, even metal frames of buildings. And the ground can crack, which is kind of crazy too. So 12 on the Mercalli scale is the highest intensity, and where you see a total damage, which is kind of crazy to think about. Okay, now, as far as intensity across the United States, there are areas where we're going to see obviously less earthquake intensity because simply these earthquakes don't happen along plate boundaries. But if you look at this earthquake that happened on August 23rd, 2011, this is an earthquake that happened in an atypical passive margin, so not along a plate boundary, and it happened close to Washington, D.C. And it was along a fault that's inactive, but there was some movement on that day, and as a result, there was a magnitude 5.8 earthquake. It was shallow. And what's atypical about this area of the United States is that this area, one, isn't prone to earthquakes, and two, the structures aren't engineered to withstand shaking during an earthquake. And then three, and probably more important in terms of intensity, is this area is underlain by sediment. So rather than solid bedrock, this whole area of the eastern United States has sediment deposits that during an earthquake will shake kind of like a bowl full of jello. So there was pretty significant shaking throughout parts of the Midwestern and Eastern United States compared to when you look out along the San Andreas Fault. There was a magnitude 6 earthquake that happened September 28th, 2004. And here, the intensity wasn't felt over a wide area, it was localized. And this again has to do with the difference in what lies beneath this terrain. And here we have bedrock. And so you're going to have shaking, but the shaking's not going to be magnified because the ground is solid as opposed to sediments, which energy can travel more easily through. So that's the big difference there between location and intensity. Now, when we talk about magnitude, it's a little bit different. Magnitude is a measure of the amount of energy released in an earthquake, and we can measure it by looking at the amplitude of seismic waves. specifically surface waves closest to the epicenter. And so when I talk about amplitude, if you think back to our lesson last week where we examined, actually this week, same week, different day, we examined P waves and S waves, and you saw that there was lag time between them. And then we talked about surface waves closest to the earthquake epicenter. When talking about amplitude, we're talking about measuring the height of the highest wave and looking at that as a record of how much energy is released during the earthquake. This is a scale of 1 to 10, although there's never been a magnitude 10 earthquake. And this scale, for every 1 unit of increase, there is a 32-time difference in energy released. So in other words, from a magnitude 1 to 2, a magnitude 2 earthquake would be 32 times the amount of energy. If you went from 1 to 3, it would be almost 1,000 times more energy released, if that makes sense. So it's more logarithmic. And so we can use both intensity and magnitude and distance to determine what amount of energy is released during the earthquake. So we measure the height of the highest wave here, right here. And then we use distance to determine how far away the earthquake occurred. And we relate the two by this scale, which gives us a measure of magnitude. So this would be an example of a magnitude 5 earthquake, although it's hard to read here. I can't make it any bigger. So if we combine all of those different scales, it's kind of crazy to think about differences in magnitude. As you move up the scale, obviously it becomes increasingly more dangerous. So the largest earthquakes ever recorded happened in Chile in 1960. And fortunately, this magnitude 9.5 earthquake was far away from any densely populated areas. And there was very little damage as a result. But this was a magnitude 9.5. And if you look at the energy release, it was equivalent to crazy amounts of energy in the terms of, like, this would be like atomic bomb explosivity index, you know? So on average, we don't have many of these large scale, high magnitude earthquakes per year. Typically, they occur in subduction zones where there's a lot of stress that builds as one plate is trying to dive beneath the other. Another example, in Alaska in 1964, there was a magnitude 9.0 earthquake, and this happened right around Easter. Actually, it was Good Friday of Easter weekend, which was fortunate because there were school closings and businesses were closed, and a lot of people were in their homes when the earth shake, rattled, and rolled. Had they been out and about, there would have been a lot more damage. This earthquake also resulted in a tsunami that swept across most of the Pacific Ocean. Another earthquake that was huge and had a devastating death toll happened in Sumatra. And this one happened on actually Christmas Eve. And it was an earthquake that happened in a subduction zone near the Sumatran Trench and in an area of the world that doesn't have the same kind of earthquake observations that we do. So in other words, they don't have the USGS, the United States Geological Survey. At the time, they didn't have anything to detect changes in ocean sea surface heights to determine if there was going to be a tsunami. And so as a result, nearly 300,000 people were killed within hours because of the tsunamis that followed this earthquake. There was an earthquake in Mexico City that did a tremendous amount of damage in 1980. This is a magnitude 8.1, densely populated area, collapsed buildings, including a hospital. So if you Google this one, you see a lot of devastation as a result. So again, like variables that impact the amount of damage include not only the bedrock or foundation, but also the time of day. This happened in the middle of the day. People were out and about, working in the streets, in their homes, driving. So that tends to have a higher frequency of, death and destruction, because of the fact that people are out and about. And also I said the type of bedrock, the time of day, and then the population, and also the economics of the area. So areas that are a little bit less well off than the United States don't have the infrastructure and the earthquake engineering to be able to build structures that sway during an earthquake as opposed to collapse or pancake. And so in Mexico City, we actually saw hospitals and other buildings that pancaked as a result of the shaking in those areas. Another earthquake that we can talk about that was devastating was the Haiti earthquake in 2012. And that's the one that they feature in the movie that you're watching today. That one was a magnitude 7. Again, it was a major earthquake because it was atypical for the area that it was in. It's a densely populated area. It's a poor country, one of the poorest in the world, and the buildings are not designed to sway during an earthquake. So we saw a tremendous amount of loss of life and damage as a result of that 2012 earthquake. So that's just kind of a synopsis of some of the larger earthquakes. Obviously, we get tens of thousands of earthquakes in the U.S. alone every year, typically along the West Coast. I'll go back to that map. So our high risk areas obviously would be here along the San Andreas Fault, up here along the Cascadia subduction zone. If we went over here to Alaska, there's also a subduction zone there. So those are the high risk areas. Now, we can get earthquakes in other areas that are on passive plate boundaries, like the Virginia quake. There's also an old fault zone. It's called the New Madrid Fault. And the New Madrid Fault kind of parallels the Mississippi River. And this was an area that at one time, millions of years ago, was a site of crustal thinning. And it's since been active. In the 1800s, there was an earthquake, magnitude 8 or so, that caused shaking felt all the way east in Boston, Massachusetts. So there are records of literally church bells ringing in Massachusetts because of the earthquake along the New Madrid Fault. So while this is not typical, earthquakes can happen in the central United States. Another instance of unnatural earthquakes, if you look at the USGS today, you'll see a lot of earthquakes happening in Oklahoma. And these are areas where there's something called hydraulic fracturing happening. And through injecting water into the ground to push gas out and up pipelines, we're getting fault lubrication and slippage that results in earthquakes in those areas. So in 2019, I think there were more earthquakes in Oklahoma than there were in California, which is crazy and unnatural to think about. So that's a little synopsis of some of the major earthquakes and also magnitude and intensity that should help you with parts 2 and 3 of the lab. All right, signing off for now. Bye.